Hey, what's up, y'all? Thanks so much for joining me on another processing tutorial. This is the last one in the series where we cover how to create the illusion of motion by keeping our camera still and moving things along the z-axis. Now, in this video, we're going to create this sort of star field effect that you can see going behind me by writing a class to describe a star and then just kind of randomly spawning them all over the screen and having them throughout their lifetime kind of travel toward us, and of course when they pass that foreground plane we'll just send them right back to the back of the sketch and have it come forward again. So let's get started taking a look at what we're going to need to put into our code to get this to work. Let's begin with our regular setup and draw functions. And we can also just go ahead and make a new tab because we know we're going to make a star class, and we'll say class star, like that. Okay, and then we also know we're going to need an array list with stars in it. We'll call it stars. Okay, and let's go ahead and make our size 640 by 480, and we are going to use the P3D renderer so that we can move things along the z-axis here. Let's make our background black. And let's just maybe go ahead and give ourselves a little star. We'll say stars.add new star, like this. Okay, and I need to give myself a constructor, so I'll say star. And I'm going to need a couple methods, so I'm going to say void update and void display, like that. And here in draw I can say, we can use a for loop, so I can say for int I equals 0, I is less than stars.size, I plus plus, and then let's go ahead and say star s equals stars.get I. And then let's run those methods, s.update, s.display. So this is kind of the same skeleton of a sketch that we used in some previous OOP videos, but this should get us started being able to put one star on the list and update and display it. So let's put some stuff in here to update and display our star. We will need a p vector, let's call it position, and we will need to set that position to something in the constructor. So let's just say position equals new p vector width divided by 2, height divided by 2, and let's put this back a little bit. Let's say like -1000. Okay, and then here in the display function we will say push matrix pop matrix and translate to position.x, position.y, position.z. Okay, and in the update function we know that we're going to want to increment z every time, so we can say position.z plus equals, let's do 20. Okay. And I think, oh, well, of course we also need to actually draw something, so I can say box, and let's say 50. So this is just a little 3D shape primitive that comes with processing. It's just going to be a little cube. And I think this is going to be enough to get us started. Let's run the sketch and see what happens. So there should be one star, should be right in the center of the screen. It should be kind of far back, and then it should just come forward as the sketch runs. Nice. Okay, there it is, right? It's looking pretty good. We're going to need a way also for it to loop back around. So when it breaks, let's say if position.z is greater than maybe 0. I'm not sure exactly where the clipping plane is, but let's start here and let's see where the foreground plane is. And we'll say, if you've reached that foreground plane, I want you to go back to where you started. So we'll say position.z equals -1000. Okay, so 0 is definitely not the right value here, right? Because it's kind of not passing that foreground plane before it gets reset. So let's try something different. How about 500? Seems okay. I might give it like a little bit more room because I want to make sure it's fully crossed that threshold. So let's say something a little bit higher than 500. Let's do 800. Okay, I think that's going to be a safe bet, right? That this is totally crossed the foreground plane before it resets. Okay, so now we need to think about how we are going to kind of randomly populate the screen with a bunch of these stars. So let's do this. Let's say, how about int density equals 100, right? And then here in setup, we'll say for int I equals 0, I is less than density, I plus plus. And I just want you to add 100 stars to our list when you start the program. Now, if we don't change this code, then they're all going to get put in the same place. So let's kind of do something more interesting with the position. So just to keep this legible, you could put this all in one line if you wanted to, but just so we can kind of see what's going on. Let's say float x equals random between 0 and width, right? And then we'll say float y equals random between 0 and height. And then let's say float z equals a random value between negative 1,000 and 0. And now, instead of these hard-coded values, we'll say x, y, and z. Okay, so this will randomize all that for us, right? And what we'll also want to do, right, is every time we reset, we don't actually just want to, only send that star right back to its starting z position. We would probably also want to randomize, again, the x and the y positions. And then we can say position dot x, position dot y. We want to randomize those again. And then we'll just send it right to the back of the sketch again. Okay, so I think this is going to be enough code here to kind of spread out all of our stars when we add them to the list and kind of get going. Let's see what that looks like. Okay. Not too bad. I think we're going to want to spread these out a little bit more in the z-plane on the z-axis. And you're also noticing, right, that they're all kind of spawning from the middle of the screen. So let's address that first, and then we'll mess around with the z position in just a moment. Okay, so one of the reason, right, that they're all kind of in the middle is it has to do with the fact that our range here is between 0 and width, right? So just for a moment, what I'm going to do is draw y'all a rectangle. So we're going to say, we're not actually going to show any of these for now. So push matrix, pop matrix, and we are going to translate to 0, 0. We're going to go back to that negative 1,000, right? And I'm going to draw a rect that is at the origin, but is width wide and height tall, and run the sketch. And y'all will see how small this rectangle actually looks when you put it far back. Okay, and so as we can see, right, if it's like only 1,000 pixels back on that z-axis, I'm going to need at least 1.5 times, right, the width. So if I wanted this to, if I wanted my stars actually, if I wanted this star field to be a little bit deeper, right, you can see I'm going to need even more than that. So this is what if I'm eyeballing it like 1, 2, 3, like 4, 5, 6, 7, 8, like almost like 10 times the width, right? So I need to go, this is 0 and this is width, right? So I would need to go negative 1, 2, 3, like maybe negative 4 times, right? So I want this to go between, somewhere between, let's say let's say 5, just to be safe, right? So I'll say negative width times molt, and then width times molt, right? So that's the range of my x value, and then the range of my y value will be negative height times molt and height times molt, right? And that should give me a bigger range of values. And then here, this can be somewhere between that and then, oh, this should be fine actually. Okay, so now we're also going to update it with that range here. And you know what? Let's also make it so that the box size, that not every star is exactly the same size. So I'm going to say float box size. And here I will say box size equals random, somewhere between, like, I'm thinking in terms of screen space, height divided by like 15 and height divided by 10. So more star sized, kind of based on how tall our window is. Okay, and then here, instead of them all being the same size, I'll say box size. Let's see what that gets us. I have to turn this back on. I think I'm going to turn this off. See what that gets us. Okay, so that's starting to look a little bit more like our star field. So there's a couple other visual enhancements I think I made to this. One of them being that not all the stars. Let's play around with the rotation of the stars as well. So let's say float rotation x. Rot x equals random between 0 and 2 pi. And then before our translate, or after our translate rather, we're going to say rotate x by rot x amount. Cool. Okay, that's giving it a little bit more variety. I might also want to just increase my density by a lot. Let's say like 800, because this is looking a little bit kind of sparse. Let's try this again. That's looking a little bit better. Yeah, okay. Let's space these out a little bit. Or sorry, let's take this code that we had from the previous illusion of motion video and copy in some of the camera settings so we can play around with our field of view, and that will make it look like things are further or closer. I'll give you a second. You can see here before setup we added this code, and then here in draw we're going to add this code. So we're now playing around. We've also increased here the furthest away that you can see, so that should make things look a little bit deeper, and we're going to play around with the field of view using the mouse. Yeah, and that's looking pretty cool. It looks a lot more spacious. You can see as I increase my field of view though that I can, that sort of perception of all of them spawning from a little rectangle in the center comes back. So, knowing that, I would want to either limit the field of view so that it's somewhere around here, or I would want to increase, the space that I am kind of spreading these out when they get spawned. But yeah, this is kind of the idea. I had a few other visual things here. Rotate. I think I was rotating on the Y somewhere like that much. So you can see adding another sort of element of rotation kind of makes these look a little bit more interesting. What else did I do? I think, there was some other code in here. I'll let y'all kind of experiment and figure out what I did. But I had it so that, as long as you were a certain distance away, you were actually not visible. So I turned the brightness all the way down, or like the fill was 0. And then as it started to go from, the maximum distance away from the camera to, maybe like a third of the way that you could get, it would brighten up so that you don't see them popping in the back. So there's something you could do to kind of control the brightness, or maybe like the alpha amount of the fill and the stroke so that it doesn't pop in like that. Oh, the other thing I was doing is I was actually having the stars actually kind of rotate a little bit just as they moved forward. So again, I'll let you all kind of experiment with this. Again, you could put a different shape. It doesn't have to be this little box. It could be a different shape. It could be another 3D model that you import. Could be anything that you want. You can play around with the color, again, making it so that they don't pop in, but you could also have them sort of twinkle if you wanted to really take this like star metaphor even further and, make them look a little bit different. But hopefully you've enjoyed these videos on illusion of motion, and I look forward to seeing what y'all come up with after doing some experimentation of your own. See you in the next video.